Biochemistry can feel like a complete pain in the ass, and the worst part, most students try to memorize every single enzyme, every intermediate, and every pathway. For your board exams, that's usually the wrong approach. Instead, focus on the rate-limiting enzymes, the high-yield enzymes, and the clinical associations. Today, let's learn about glycolysis without crying. At its core, glycolysis is simply the breakdown of glucose. So, the carbohydrates that you eat, rice, potatoes, bread, pasta, even the bun on your burger, are eventually broken down into glucose. That glucose then enters glycolysis, where it's converted into pyruvate. Since glucose has 6 carbons and pyruvate has 3 carbons, it's important to know that one molecule of glucose gives you 2 molecules of pyruvate. The overall reaction looks like this. So you get glucose with 2 ADPs and 2 phosphate ions and 2 NAD plus gives you 2 pyruvates, 2 ATPs, 2 NADH, 2 H plus, and 2 H2O. Don't stress about memorizing this equation. It's not particularly high yield. It's just useful in understanding what glycolysis is trying to accomplish. Now, here is where the actual steps are that you need to know. Glucose is first converted into glucose 6-phosphate. This is catalyzed by either hexokinase or glucokinase. Now here's the high yield difference. Hexokinase has a high affinity for glucose, meaning it works even when glucose levels are low. Glucokinase has a low affinity for glucose, which means it becomes more active when glucose levels rise after a meal. So if someone ate a big meal, right, which enzyme kicks in? It's going to be glucokinase. That's when it kicks in, right after, there's a spike in glucose levels. So if you're studying for board exams, this distinction is worth remembering. Next, glucose 6-phosphate is then converted into fructose 6-phosphate, and fructose 6-phosphate becomes fructose 1,6-bisphosphate. Now, this step is catalyzed by the enzyme phosphofructokinase 1. This is the rate-limiting enzyme in glycolysis. It's important to know this, okay? Now, if there's only one enzyme you need to remember for glycolysis, make sure it's this one, phosphofructokinase 1. Now, another important molecule is fructose 2,6-bisphosphate. Fructose 6-phosphate can also be converted into this using the enzyme phosphofructokinase 2. Now, what is the function of fructose 2,6-bisphosphate? It's to speed up and promote phosphofructokinase 1. So it's like the gas pedal. It's the catalyst. By the way, if you're finding this information helpful and want more Step 1 content, follow MedBite so you don't miss on the next pathway. Now, we're going to skip several intermediate steps because they are much lower yield. Eventually, glycolysis reaches phosphoenol pyruvate, also known as PEP. PEP is then converted into pyruvate using the enzyme pyruvate kinase. And that's the final major enzyme worth knowing. And now you've covered the 3 most important enzymes in glycolysis. We've got hexokinase and glucokinase, phosphofructokinase 1, and pyruvate kinase. Okay, these are the 3 enzymes that you need to know. Once pyruvate is formed, it has 2 major fates. If there's oxygen, it's going to proceed into being turned into acetyl-CoA and continue into the TCA cycle. If there's no oxygen, then it's going to be converted into lactate, and that's exactly what we'll cover in the next video when we tackle the TCA cycle. Follow MedBites and let's survive biochemistry together.